Welcome back. My previous video focused on 45, 45, 90 triangles. Now we're going to get into the 30, 60, 90. We're going to start with a diagram of a equilateral triangle. There are any diagrams I do here, not necessarily to scale. So this is a 60, 60, 60 triangle. And we never call it that. We just call it this equilateral triangle or equiangular triangle. So all these sides are the same. Now we're going to make up a number for these sides to be, and I'm going to choose 2. It may seem weird to choose 2 instead of 1, but you'll see why this is in just a moment. So all these are 2. And we're going to split this right down the middle because we're not interested particularly in this one, but with a 30, 60, 90. So right down the middle here, we'll bisect this 60-degree angle, turning them into 2 30-degree angles. There's your 90 still there. What that does to this side makes that 1. And then we just have to find out the height of this. Now, similarly to the 45, 45, 90, it's all based on the Pythagorean theorem. So we have this leg 1. This leg here is unknown, so I'm going to leave that as B. And our hypotenuse of this triangle is 2. So working this out, we have 1 plus B squared equals 4. B squared is 3. And then B is root 3. That is where our base diagram for the 30, 60, 90 comes from. So this one could be a lot to look at. So I'm just going to draw a second diagram with just what we need. Our small angle here, 30. 60 down here, 90 being the boxy thing. So this is 1, the hypotenuse is 2, and this side is root 3. A lot of students tend to confuse the 2 and the root 3. You want to make sure those are in the right place. And I'm usually a fan of formulas, but sometimes it helps us look at these in just words. So we're going to see the relationship between these things with words. We're going to base everything on the short leg. So we could say this, that the hypotenuse is twice the short leg. So making the language very simple, I could say the hypotenuse is twice the length of the short leg, but that's easy to remember. The hypotenuse is twice the short leg. And the long leg is, how should we say this? We could say the short leg times root 3. Many of the examples you're going to get are going to work forward from this. So we're going to start off with the least tricky ones. Again, least tricky doesn't mean not difficult. It just means that everything is sorted in its place. So we have 30, 60 here. And let's throw a 5 in here. So if this is 5, based upon the diagram or the rule, the hypotenuse should be twice that amount. That's 10. And the longer leg would be the short leg times root 3. It'd be 5 root 3. You could also choose to use as your base diagram to have some variables here like x's, like I did for 45, 45, 90. This is x root 3, 2x, and x. Let's pick a different starting point. It's a new problem. Didn't mean to erase that, it's okay though. Let's start with a hypotenuse. 16. Matching it to this diagram, this looks like 2x. So that would mean that x would have to be 8. X is 8, looking here again. Then we have x root 3. That, of course, is if everything's oriented in the correct direction. So problems can become difficult if they're oriented differently. If I put this upside down or at an angle, I have to make sure selecting what is the correct short leg, hypotenuse, and so forth. So we need some information here. Let's say if I were to say this is 60, then it would make sense that this is 30 here. The short leg should be opposite of the 30. So the short leg is over here. This is the long leg, and this is the hypotenuse. If 7 is the short leg, I want to use those relationships from before. Let me write that out again because this is very important to know this in terms of the words. The hypotenuse is twice the short leg. And we could say the long leg is root 3 times the short leg. Or the short leg times root 3. So here's our short leg. The hypotenuse is twice the short leg, so that should be 14. And I wrote it over there. That's not the hypotenuse, though. The hypotenuse has to be across from the right angle. So it could be tricky if it's not oriented the way we're used to. Here's the hypotenuse. Some people say like you could take this box here and kind of draw an arrow here, and that points to the hypotenuse. Oops, deleting things I don't want there. Okay, so this is 14, and then the long leg is root 3 times the short leg. So I'm going to take the short leg, which is 7, and multiply by root 3. We'll try one more example where things are kind of going in the forward direction. So you need to know some information about the angles. Let's say if I say this is 30, so all the blue for this example is going to be the original problem. And let's say this side is 8 root 3. How do we find everything else? So all the findings are going to be in the orange. Now, this has to be 60 to make it add to 180. So we have a 30, 60, 90 triangle. That's a special right triangle, so we could use our diagram. Matching everything up, so this looks like it's just a little bit on its side. We can equate this to this. That seems like x should be 8. So 8 would be down here. And the hypotenuse is twice the short leg, so that's 8 times 2. That's 16. Where this gets confusing is when we see root 3s where we don't expect them to be. So a lot of times root 3 is on the long leg. It's on the long leg in the diagram. It's on the long leg in this problem and this problem, but it doesn't need to be. I mentioned in the previous video, sometimes things are presented to us that seem confusing, and it's done on purpose, but it's not done with a mean intent. Its purpose is because life is full of, I don't know what I'm saying, but you know what I'm saying. So it's all to prepare us for the unexpected, basically. So I'm going to recopy this diagram here of the 3690 with x's. x's instead of the numbers. It's a little bit sloppy. So we have x, 2x, and x root 3. The sorry for the pause there, just making sure this is actually recording. I'm going to do two things. I'm going to kind of put a 306090 on its side, and I'm going to put a radical where it might not like it to be. All right, so the red will be the original problem. Blue will be our work. So first things, I would fill in the 30 here. Then identify long leg, short leg, and hypotenuse. So hypotenuse is opposite this. It's pointing there. This is the hypotenuse. Our short leg is opposite the 30-degree angle. That's the 10 root 3. And our long leg is opposite the 60 degrees. That's not labeled with anything yet. So in words, we said that the hypotenuse should be twice the short leg. Is twice the short leg. Short leg's 10 root 3, so that means the hypotenuse should be 20 root 3. Another way to look at this is that the short leg in the base diagram is x, therefore this is x. And we're trying to find 2x. So 2x would have to be 20 root 3. X root 3, that is the long leg, which is telling us to have the short leg and multiply by root 3. The short leg already has root 3 in it, but that doesn't matter. We're still going to take short leg times root 3. So to be the long leg, it is short leg times root 3. We have two of the same roots, two radical 3's. That gives radical 9, which in turn is 3. But remember, you don't have to think about all that. It's going to be the same radical back. So this is going to be 10 times just 3, which is 30. Notice that the long leg here, in many examples before, we had a radical. Now it's a whole number, so that can happen. Let's go through another example, given different information this time. Notice I'm leaving all the facts up here. This whole diagram is just a fact here about 30-60-90 triangles. I should have labeled this though. Okay, so this is the 60 down here. This is the 30, and we know where the 90 is. So what if I take the long leg and make that some kind of whole number? So what is this is 15? How do I find everything else? It's a bit annoying, to be quite honest. So what you want to do is match that long leg up with the base diagram and make equations. Here's the long leg in this one, long leg on this one. Set those equal to each other. So we could say 15 equals x root 3. Now we have an equation, so we got to isolate x. You're going to do that by dividing by root 3 on both sides. This will cancel. x is 15 over root 3. Now, this is not a proper way to leave an answer. We have to rationalize this. If you're not sure what I'm doing right now, what you want to do is look up how to rationalize fractions with radicals. Because I don't really want to cover that in this video here. Okay, the main idea is that we can't have a radical in the bottom of the fraction. So we fix it like so. So this is, we solve for x. So this is the short leg, 5 root 3. Let's pause for a second. So this says that the long leg should be the short leg times root 3. Let's see why that makes sense. Think about this times root 3. This times root 3, let's see how you get to that. It checks out. Now, the last thing we have is the hypotenuse, and the hypotenuse is supposed to be twice the short leg. Our short leg is 5 root 3, so we want to double that. That's going to become 10 root 3. And we have that triangle solved. This is the harder of the two special triangles, special right triangles. Okay, so I'd like to do one more example of this. So I'll put the 30 up here. Let's pretend this is a straight box, and I'm going to make this a whole number. So what is that side that I labeled? I want to decide whether that's the short leg, long leg, hypotenuse. So look where everything is. There's our 30. That means over here, this should be the short leg. And this is a long leg. This is our hypotenuse here. Our 60's here. So the best way, there's a few different ways to do it, but the best way I found is just to take the long leg and set it equal to x root 3. Setting those equals, so 12 equals x root 3. So when we find x, x is one of our lengths that we need anyway. We have to rationalize this. Sorry, we have to solve it first and then rationalize. So we have to divide by root 3, divide by root 3. And let me show the steps for the rationalization. Because sometimes these things could be a little rusty. So we have radical on the bottom. We don't want that. You could multiply it by both radical 3 top and bottom. Comes 12 radical 3 over 3. That reduces to 4. So 4 root 3. Now the radical's on the short side. There's no rules saying like which side can have a radical. It all depends on what length you're given, what you're starting with. And then we're going to employ the rule that the hypotenuse is twice the short leg. There's our short leg. Twice this is 8 root 3. And then we have our triangle solved.